Hey everyone, hope you're doing well. So here's a video to go along with today's lesson. And today's lesson we covered a lot of stuff, but we're going to revisit it over the next couple weeks because it's tough to take in all that stuff in one go. But basically what we did is we looked at all the different kinds of array things there are in Python. And there's 4 of them total. First one we're going to take a look at is called the list. And so the list shows up in purple, means that it's a special command. And so I'm going to make a capital L list. And the way that you make a list is you square brackets, and then you put in what you want to store inside of this list, separated by commas. And in many programming languages, arrays like this, they all have to be the same type. That's not true for lists. Lists, you can put anything you want inside of them. So I can put like the number 1, and then I could say hello, and then I could put in pi, and I can put in a boolean. Just like that. And so now I got a list with 4 different kinds of things in it. And I can print it out, so I can do print list, not that list, this list. There we go. And it prints it out, and we can see everything that's inside of that list. In this environment, when we're working just in the shell, you can also do that, and it'll do the same thing. But in your programs, if you want to see what's inside, you do have to use the print command. Okay? So, that's the list. And the most basic thing that you can do with a list is you want to access what's inside of it, and possibly change what's inside of it. So, for example, if I wanted to get access to this 1, I would need to say list, and I need to put some square brackets, and inside of those brackets I need to put down the index that corresponds to the position of what I want to find. So for example, if I want to get this 1, I need to give the index of that 1. Now here's something that can be a little bit confusing about computer science, is in computer science we don't start counting at 1. This is not in position 1, even though it's the first element. It's actually in position 0. And that's because in computer science, we always start indexing from 0, not 1. And it doesn't have anything to do with the fact that computers are binary. This would have been true if we used a different kind of system as well. But the reason is because when computers first started being made, memory was extremely valuable and extremely big. So, like big in terms of like how big a hard drive would have to be. It didn't store a whole lot. And the memory locations are all given by memory addresses, right? And so if you want to make them full use of your memory, there is a memory at position 0. Right? If we have just 1 bit to say something, that 1 bit can either be 0 or 1. If we had, say, if it worked in, say, decimal, then we would have 1 character representing, and that could be from 0 to 9. Right? So it doesn't matter what system we use, decimal, binary, hexadecimal, whatever, the first number is 0 every time. And so we don't want to waste that 0. We want to be able to use that and make full use of the memory that we have, or at least back then. And so that's why they started counting from 0, in order to use the full memory that was available, rather than start from 1 like everybody else. So that's why we start counting from 0. And so if I put a 0 in here, it's going to give me the first element right there. Hit enter, and I get 1. I can do it again, and I can say give me what is in the second position, which means I need to give an index of 1. And it'll give me hello. I can do it again with 2. I get pi. I put in 3, and I get my true. Alright? So that is how you can access stuff in it. And you can also change them. So what if I want to change pi to e? So I'm not, what the hell? I don't want an arithmetic error. No. I'm going to set it equal to 2.71, which is the first 3 digits of the constant e. If you get into calculus, you'll use that number quite a bit. And so I can take a look at my list again, and I've replaced pi with 2.71. So that is how we can get access to different parts of our lists. as well as change things. And those are your basic operations that you often want to do. You can also split lists into different parts and add them together. So I'm going to make a big list. So I'm going to call big list. And I can combine lists by adding them together. So I'm going to say big list is equal to list plus list. Now let's see what's inside a big list. Well, now we got 8 things inside of it. And what it did, it took the list. So this is the first list from this one. And it added itself again. So now we got a list of 8 things rather than 4. And so adding lists together is a good way to combine them and make a bigger list. Subtraction doesn't work, unfortunately. It doesn't make sense to necessarily subtract things. But adding lists, that's how it works. And we can split this list into parts. So I say I want my big list, but I only want the first half. Well, or maybe I say I want to get these ones. So it starts at 2 and it ends at 2, 3, 4, 5. So this is index 5, that's index 2. So what I would want to do is I want to do 2 to 6, not 5. Because just like how the range works, remember when we do range in our for loops, it doesn't include the upper limit. Same thing here. So I'm going to do 2 to 6, and it gives me everything between those ranges except for the upper limit. 6 would be right here. It does not give me that one. So that's how I can get a piece of a list. Could be a useful thing to do. You can also get, say you want everything from the beginning. Well, you can say, give me everything from the beginning up to but not including index 4. It gives me the first half. I can do it the other way around. I can say give me everything from 4 to the end. And it gives me the second half. It looks the same. How about I do 5 just to show that it is in fact different. So it's giving me these ones right here. Alright. So that is how you can get pieces of lists. What else? Well, sometimes you want to add to the end of a list. So let's take our big list. And we're going to use some commands now that go along with our list. After you hit dot, you can see that a whole bunch of different things show up. And so we're going to take a look at some of these. I only covered a handful of them in class, but I'm going to try to see more of them in their video here. And so the first one we're going to look at is the append. And what the append does is it just simply adds whatever you put into the brackets here at the end of our list. So I'm going to say this is at the end. Alright, and now I'm going to check my big list again, and you can see that my string got added to the end of the list. That is what append does. It just adds things to the end of the list, or appends things to the list. Okay? So, now let's take a look at what else we can do. So how about we do pop? So pop does 2 things. Pop will remove something from the list, and it will return it. So if I say big list pop, and say I want to pop that hello, I need to give the index, which is 1, and it will print it. See, that's the one that we're talking about, so I said pop returns what it is that you popped. But if we take a look at the list now, again, we can see that that hello is now missing. It's been removed from the list. So pop serves 2 purposes like that. Primarily it's used to remove things from the list, but it's also used in case if you want to return that thing as well. So that is a useful one. Next, what else do we have? We have index. So say big list dot index. And what this does is it's a search algorithm. And so what you can do is you can say, okay, I want you to find this particular element in your list and tell me where it is. So say I want to find true. So I can say, okay, where is true inside of the list? Well, that gave me 0. That's not, oh, that's because 1 evaluates as true. How about we give something else? Booleans are odd that way because a lot of things can be evaluated as a Boolean without actually being a Boolean. Let's find the hello. So there we go. It gives me the number 4, which corresponds to the position of this. Which means that if I do big list and I say, okay, give me what's in position 4, well, it's the hello that I looked for. Alright? So index can be used to find the index of a particular element just by searching through. So we did append, we did pop, we did index. Let's take a look at sort. So this particular array, or list I guess, cannot actually be sorted. Let's try sorting it and see that it doesn't work. So I did big list and then sort, and I get an error. And the reason is because you can only sort things that you have less than or equal to or greater than is defined. So 6 is greater than 4, right? So that is a defined comparison. Makes sense to compare two numbers and ask what's bigger. You can also do the same thing with strings. So I can say, is A less than B? And it's going to tell me true because it's when you're comparing letters or strings, it does so alphabetically. Alright? So it's just comparing, okay, which comes sooner in the alphabet. The sooner you are in the alphabet, the lower you are in this comparison. So as long as you can do these comparisons, you can sort it. And so typically, you can only sort numbers or letters, or strings I guess. You can compare strings and you can sort numbers and do that, but you can't do between the two, which is what's happening here. It tried to sort them, but it said, okay, it got to a scenario where it says, okay, is A less than 5? Well, what the hell does that mean? Who knows? Doesn't make sense. So that's why we got the error. So let's make a list of numbers so we can see how the sort works. So I'm going to call it the num list. And it's just going to have some numbers. I'm going to randomly throw a bunch of numbers in there, blah, blah, blah. Good enough. We got our num list. Now let's sort it. Num list dot sort. And now let's take a look at our num list and see if it's sorted. Well, look at that. Now they're all nicely arranged. But what happens if you want to go and sort it the other way around? Instead of smallest to largest, what if you want largest to smallest? Well, sort isn't going to do that for you, but there is a way that you can get around it. And that is by using negative indices. So say I have my num list here, and we know that if I put in, say, 1, it's going to give me the 6, right? And if I put in 0, it's going to give me 3, and so on and so on and so on. But what if I put in -1? What do you think it's going to give me? Well, it's going to give me the last element. So negative indices, when you call it like this, says give me the last element or start counting from the last element. So this is -1 is give me the first element from the end. I can do num -3, which would be the third element from the end, which gives me this one, etc. So if you wanted to sort it the other way around, this is already kind of sorted both ways, but if you get it access to the numbers in the opposite direction, using negative indices, you can go from largest to smallest. So that is a way that you can kind of get around sorting from getting a largest to smallest sort without actually having to sort largest to smallest. Just read it backwards. Next thing we want to take a look at is how can we use these in loops, because often you typically are going to want to loop through a list and operate on everything inside of that list. Also note that this sort would also work if the list was just filled with strings. You can sort all the strings like that. How about we show that first? So alpha, we'll make an alpha list. That's not how you spell alpha. That's how you spell alpha. So we've got an alpha list, and we're just going to put a couple of letters in there. Say T and A and E. I'm going to put a capital in there to show you what happens when it's sorting capitals. W, M, B, I guess. Sure, whatever. And now let's sort this thing. So alpha list dot sort. And now let's take a look at our alpha list. And you can see that it kind of got sorted, but why is capital E before A? A comes before E, right? I remember that from elementary. I'm pretty sure that hasn't changed. Well, what it's doing is technically it's sorting by the ASCII values. And if you look at the ASCII values, capital letters have lower values than lowercase letters. So it's taking a look at the ASCII values of each one of these characters and sorting by that. So these get sorted alphabetically, but capital letters will come before that. Also, punctuation would also interfere with that because I think punctuation has a lower ASCII values than even capital letters. At least many do. So something to be aware of. It's not going to be sorting necessarily how you think. It's going to be sorting by ASCII values, which is pretty close to sorting by alphabet, except for, the capital letter issue. Alright, so now let's see how we can loop through a list. So you use a for loop for looping in a list. And I'm going to say for element, doesn't matter what you call it, it doesn't have to be element, it could just be I. But I like to name my variable something that's descriptive. And so these are going to be the elements in that list. So I'm going to say for element in, say numList, print element. And so what it's going to do is going to go through every single number in my list here, because we're doing it with our numList, right? And it's going to assign to the variable element the values each time. And every time it loops, it's going to go to the next one and assign it to element. So if I hit enter, it's going to print out every single one of these numbers in order. Just like that. Alright? So that is how you can loop through a list. Very useful thing. You can also ask if something is just simply in a list. So we saw that we can search a list and get its index, like this. But what if we don't actually care about the index? What if all we care about is whether or not something is in the list or not? Typically, that is something that we often want to do. So what you can do is you can say, say we'll use our numList again. I can say, is the number 4 in numList? And it will return either true or false, depending on whether or not that number or element is in the list. So 4 is not in our list, so it returned false. Or I could say put in 8. 8 is in our list. It's right there. Nope. And it returns true. So that is a way that you can check whether or not an element is in a list or not, if you don't care about where it's in the list. Has some uses. We're going to use this in our next game that we make all together. I'm thinking we're going to make Codebreaker, and that's going to be a good use of the different ways that we can use arrays. So that is pretty much everything I wanted to show about lists. Let's move on to the next array type. It's not really array, but well, they're all in the kind of the same family. They're objects, variables that just hold on to many different values or objects inside of them. Oh, wait a minute, I need to show you how to do multidimensional arrays, because our major assignment for our array unit is going to be making Battleship. And Battleship requires a square playing board, and that is well suited for a two-dimensional list. So, I said you could put any kind of variable inside of a list, and that includes other lists. And that is how you do multidimensional lists. So you can say this is going to be a list that's 2D. I did want to do 2D list, but you can't make variable names start with a number, unfortunately. So, and we'll make that list, and inside of that list, we'll just start off with that, and I'm going to append some lists to it to make it a multidimensional list. So we've got list 2D, and we're going to append the following. We're going to add 1, 2, 3, 4, 5, 6, 7, just like that. And so we've added a list to our list. Listception. So let's take a look at our list. And now we can see 2 square brackets, which means there's a list and a list. Now let's append another list. Append. And let's put in, I don't know, I'm just going to do some random stuff in here. Let's close that. Blah, 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 blah. Good enough. And we'll take a look at our list again. And now we can see that we got 2 lists in there. This one and this one. So that's great. But how do we access those now? We know how to access stuff inside of a list, but how do you access stuff inside of a list inside of a list? Well, this is how you do it. So you start off the same and put square brackets, and inside these square brackets you need to put the index of which list inside list you want to access. So I'm going to try to get access to this 67 right there. That 67 is in the second list. The second position in a list has an index of 1, so I'm going to put a 1 there. Now I'm going to put another set of square brackets, and now inside of those square brackets I'm going to say where inside of this list, this inner list, I want to access. I want this 67. The 67 is in position 5, which means it has an index of 4. And so if I hit enter, I get 67. This is how you can access things inside of a list inside of a list. And you can keep on going. I could put list inside of a list inside of a list inside of a list. That goes on forever. I don't know why you'd want to do that, but it's certainly possible to do. Alright, so that is how you do 2-dimensional lists, and that's how you access the stuff inside of them. Alright? Now let's move on to dictionaries. Dictionaries are very useful, but take a little bit of time to wrap your head around and how to use them effectively. So we're going to see some examples of how to use them effectively later on, but for now I just want to show you how they work and how they operate. So dictionary, I'm going to call a dictionary called dic, because why not? And dictionaries are made with these curly brackets, braces. And dictionaries are different because they don't have just elements inside of them, and they don't have positions. That's the most important thing, is they don't have positions. You do not access things as an index. Instead, you access them through keys. So, I'm going to make a dictionary where the keys are going to be cities, and the values are going to be the name of the hockey team inside of that city. So, how it works, I can say, okay, Calgary is a string. I can use a string as a key. That's perfectly fine. Any of the basic types you can use, but not all of the array types you can use as keys. So strings, booleans, integers, floating points, they can all be keys. Lists, however, cannot. And dictionaries cannot. But we will find there is an array that you can use as a key. And that's actually what makes that particular array very useful. And so here I'm going to put flames. Just like that. And then I'm going to do, say, Edmonton is the next key. And then I put colon. So you always separate the key and its value with a colon. And then the commas separate the key value pairs. And so here will be Oilers. And you know what? That's probably good enough for a dictionary. So let's take a look at what's inside of it. And we can see that we got 2 pairs inside of it. Now how do I access the things inside of the dictionary? Well, use square brackets just like before. But instead of giving the index of which one you want, because these are not necessarily ordered at all. Dictionaries have no ordering whatsoever. Instead you give it the key for the value that you want. So if I want to get the Flames, I would say Calgary That's the key, and it returns flames. Alright? So while the keys are restricted or what they're allowed to be, the values can be anything. Just like in the list contain anything, the values in a dictionary can contain anything. They can contain objects, they can contain functions, they can contain lists, they can contain other dictionaries. Whatever you want to put in there, it's fine with it. So, what you want to use these for? Well, one thing I did for my version of the Battleship game was I stored the position of every ship inside of a dictionary. Because on the game board, I can't put the position of store the ship's position on the game board, because that would show the player where the ships are. I need to keep them hidden, which means I need to store the position of the ships in something else, rather than the 2D array that represents the game board. So I put them in a dictionary, and I used the key, which is going to be the name of the ship, was it a battleship, an escort, destroyer, or the carrier. So 4 different ships. And next to it was a list of tuples, which is something we haven't seen yet, that stored all the positions for that particular ship. So a large ship like a carrier occupies 5 different spots, and so I had a list of 5 different spots that it occupied. And that gave me an easy way to go through all of the ships, check whether or not the player hit them, as well as if they did sink a ship, I already knew which ship they sunk because the key told me what that ship was. So, that's one useful thing. Another thing you can use it for, I've used it for, is to switch between players. So, say you're making a 2-player game like Tic-Tac-Toe or something, which switches back and forth through people's turn. You would need to handle some way to be able to switch and keep track of whose turn it is. And you'd think, okay, I could make a function to do that. Well, I can do the same thing with a dictionary, and a dictionary would do it far easier and in far less content to code. So this is how it would work. You could say player equals player 1. So I'm going to say initially that whoever the current player is, that is going to be in the player variable. And I'm saying right now it starts off as player 1. And now I'm going to make a dictionary called swap player. And it's going to contain 2 things. That's not how you make a dictionary. You need curly brackets, just like that. So I'm going to say player 1 is going to be a key. And the value is going to be player 2. What this is going to do is when I pass player 1 into my dictionary, it's going to return player 2. So if it's player 1's turn, I pass it in here, it then switches the turn to player 2. Likewise, I'm going to say player 2 key then returns player 1. Just like that. You got to make sure that I keep the spelling all correct. And so if I pass player 2 into it, it will return player 1. So now, what I can do is I can just keep on passing whatever's in player to this swap player dictionary, and it will switch to the next player for me. And this doesn't have to work just for 2-player. This could work for n player. And each value, each key would be for that particular person, and the value would be who gets to play after that person. So player 1 could go to player 2, and then player 2 to player 3, and then player 3 to player 4, and player 4 back to player 1. That would work, and a dictionary would be well suited for it. So let's say player equals swap player, and then square brackets player. So I'm passing whatever player is to my dictionary and assigning what it returns back to player. So I hit enter, and now player is player 2. I do it again. Now the player is player 1 again. And I can keep on doing it back and forth. And all it's going to do is it's going to keep on swapping between them. That is actually a pretty useful thing to do. And I got something that can do that with 1 line rather than the 5 or 6 lines you might need to do if you're using a function. So, dictionaries have a lot of uses, and they're probably the most underused of them, but it can be a little bit tricky to wrap your head around how can you make the full use of them. One other thing that is good about dictionaries is, unlike lists, and Python's lists are notorious for being slow, so you don't want to do big operations with them, but they're perfectly fine for little stuff like this. But the dictionary, on the other hand, is actually quite optimized. So it doesn't matter how big the dictionary is, it takes a constant amount of time in order to actually access anything inside of that dictionary. So you can have a huge dictionary, and it's not going to slow your program down. But a huge list, on the other hand, absolutely could slow your program down. So that's another thing that you might want to be aware of. Last thing that we're going to look at for dictionaries is you can also loop through them, but you need to do a little bit of additional work in order to get it to work. So we're going to make a for loop to loop through, say, this dictionary here. So I'm going to say for key in. So I'm going to loop through the keys in the dictionary first. You can loop through it two different ways, through the keys or through the values. Typically you'll do the keys because you can access the values that way. But it doesn't work the other way around. You can't give the dictionary a value and get a key back. It only goes one way. Key will get you a value, value will not get a key. Because while the keys are all unique, the values may not be. So I'm going to say for in dic keys, that's not how you do it, keys, I'm going to print key. So same idea as before, when we saw it here. So we did for something in array, print that something. We're doing for something in the dictionary's keys, print that key. And it printed out the two keys for us. You can do the same thing with values by changing it to values. I'm not going to change these, but it'll work the same way, and it'll, whoops, that's not supposed to happen. There we go. And it'll print out the values inside of that dictionary. So that's how you loop through the keys and the values. You can add new stuff to it very easily. You don't even need to use append. So I can take my dictionary and I can say, okay, I'm going to give it the key. And it doesn't have to be a key you already made. You can make a brand new key. So this new key is going to be Vancouver. That's not spelling anything yet. Vancouver. And I'm going to give it the value of Canucks. There we go. So, just like that, you can add stuff to a dictionary. And now I got 3 things in there. Calgary, Edmonton, and Vancouver, as well as their teams for the values. Alright? So that is the dictionary. And those are your 2 main types of array-like things that you're going to use a lot in Python. But there are 2 more, and we'll take a look at them right now. So the next one we want to look at is called a tuple. It looks like that. I don't know why they call it a tuple. Doesn't really make sense to me, but it is what it is. And how it works is a tuple is made with round brackets. So lists are square brackets, dictionaries are squiggly brackets, tuples are round brackets. And you can put whatever you want in them. Just like with dictionaries. So we can take a look at inside of it. There we go. We can access them exactly the same way. So that gives me hello. I can do the same thing, do it backwards. Alright, so all that is the same thing as with lists, but there's one important difference. You cannot change anything inside of a tuple. You cannot add to it. You cannot assign a new value. Like if I try to do this, it gives me an error. See, type error, tuple object does not support item assignment. I cannot change anything inside of it. Once the tuple is made, it's fixed. But, so you might ask, why would we even want anything like that? Lists are clearly far better. You can change them, you can do anything you want with them. Why would we want something that you can't change? Well, one reason is because tuples are faster. The fact that they're more restricted means that they're also better optimized. The more things you can do with an object, the trade-off is typically that it's less efficient. So when something is very restricted, it's typically much faster as well. So there's that trade-off between what is easy and can do a lot of stuff versus what is very restricted but runs very fast. The other thing, and probably the more important thing, is that tuples can be the keys to a dictionary, unlike all the other array types. None of the other array types, including the one that we haven't seen yet, can be key for a dictionary, but tuples can. So I can say dictionary, I'm going to put in a tuple here, say 1, 2. And I'm going to assign goodbye. That works. And so we can take a look at our dictionary. And we can see we now got another set with the tuple 1, 2 as being the key and goodbye as being the value that goes along with it. This I have found to be very useful when I want to store positions or refer to positions, because that way I can say, okay, what's at position 1, 2, and the value would be whatever stored at position 1, 2. You can kind of think of them as being like a vector, perhaps. This might be how you want to use it. So you can do that with tuples, but you cannot do it with anything else. Like if I try to use a list as a key, no, doesn't work. So only tuples can be used as dictionary keys. And that's basically all there is to tuples. They're like lists that you can't change, but you can use them as keys. The last kind that we have is called a set. You very rarely use it, but it does have a very useful property for certain problems. And so how you make a set, so you can see set like that, turns color. Those are for converting things into a set, so we'll see how that works in a moment. And how you make a set, well, sets actually use the same brackets as dictionaries, curly brackets. The major difference is that there's only values inside of a set, but there are no key value pairs. And so that's how it can tell the difference between a set and a dictionary. So let's put some numbers in here. Blah, blah, blah. And I'm going to put a bunch of stuff at the end like that. And a 4, 5, whatever. And so now I got a set. But this, you'd think that's what my set is, right? That's actually not what my set is. Let's take a look at what my set is. And I want you to try to identify what it is about a set that makes it different from all the others. So this is what I put in, right? This is what I got out. And some of you were noting that in our class example, it happened to turn out to be sorted. This one, on the other hand, is clearly not sorted. So sets do not sort, unfortunately. But have you figured out what's different about these? What's going on? It's because every element in a set must be unique. You cannot have any duplicates inside of a set. And notice I got duplicate 4s here. I got a whole bunch of 1s I put in on purpose. But there's only one. There's only 1 4. 1 of everything that showed up in here. So that is what the unique property of sets are and why they're useful. You can use them to get rid of any duplicates inside of any other type of array, except for dictionaries. And so if you just want to know about the unique things and you don't want to know about duplicates, sets are useful for that. And that's basically all there is to sets. Last thing is what about converting between the different types. So we have we still have our big list, right? Yeah. Let's see what's inside our big list. So we got all sorts of stuff in there. Alright, we can turn it into different types. So these three that I'm going to show you all can be converted to the other types of arrays very easily. So I can take big list and I can convert it to a tuple, like this. So I'm going to tuple big list. And you can see now I got a tuple. The only real difference is instead of square brackets, we got round brackets. Alright? And it would return it. So if for some reason you want to turn a list into a tuple, that's how you do it. You can also turn it into a set. And now we got a set. Notice that it got rid of all of the duplicates. Hello is only there once. 2.7, 1. This is the end. What happened to true? Why is true not in there? Well, I'm going to show you. I'm going to ask, is 1 equal to true? Yes, 1 is equal to true. Might seem weird, but every integer can be converted into a Boolean, or interpreted as a Boolean. So 0 is equal to false. 1 is equal to true, and I think any positive is actually equal to true as well. No, just 1 and 0. My bad. But now we know, right? So that is why true got rid of. It got rid of true, because to the computer, true is the same thing as number 1, and sets do not have duplicates. So it said, oh, I already got a 1 in there. I don't need this Boolean 1. So that's why that happened. Yeah. So that is arrays in a nutshell. I know that's a whole lot of stuff that we covered, and we're going to look at more aspects of these in the future. But main idea is I want you to know that these things are there, what they do, and just be aware of the things that they can be applied to, the kind of operations that they're associated with, so that when you are programming, maybe you're not going to remember exactly how to do it, but you know that it's there, you know it's possible, and so a quick Google search will help you find out how to do it. But if you don't know that is possible, you're kind of stuck, right? You can only go and search for things that you know exist. Anyways, that's everything I wanted to show you for today's class. On Monday, we are going to, I think I would like to get started on a new game. So we're going to modify our guessing game, get rid of the guessing game parts, but the structure of it is still actually pretty useful for many other games. Lots of games have that kind of structure. So we're going to make a new game. We're going to apply some of the stuff that we are learning here with our lists and arrays and whatnot. And yeah, I will probably introduce another assignment next week. I'm thinking maybe Thursday. It's going to be another one of the sort of function exercises. So you're going to be making functions that do stuff and that return something. And there's going to be, once again, a testing program that goes along with it that will test all your functions and make sure that they work appropriately. And then when we're all done with that, we will take a look at making the end assignment for this module, which is going to be the Battleships game. Alright? So, have a good one, enjoy your weekend, and I will see you all on Monday.